Okay, so in this tutorial, we're going to look at absolute and relative paths, and we're going to focus on relative paths and how you can use them to make your scripts more portable, and also how you can use relative paths to separate out your raw data from your derived data, which is kind of a key aspect of good data management. Okay, so here I am in my home directory. We can visualize that using the pwd command, which is print working directory. Okay, so to illustrate some of these concepts, let's start by making a couple of directories in here. Okay, so now if I type ls, we can visualize these directories that we've just created. The way that these are displayed here, these are actually relative paths. So let me show this with a diagram. So this is a diagram illustrating what's called like a directory tree. So that's how you can visualize or think about the way that the file system is created on Linux or Unix-like system. So at the top, you have what's called the root. This is the root directory. And in this case, we are in /root /home /awesome_t. So we're done here. And we've just created these two directories here, raw data and scripts. So if we're looking, suppose we have a file in the raw data directory called raw_data.txt, we can express that file as an absolute path, which would look like this. Or alternatively, if we were in a scripts directory, if this was our working directory, a relative path to this raw data would be ... to go up one level in the directory tree, and then raw data for the directory, and then raw data.txt for the file. So let's create that file in the raw data directory. So I'm going to echo a piece of string into a file in the raw data directory called raw data.txt. So if I do an ls in raw data, we can see that that file is there. And we can visualize the content of that file using a relative path or using an absolute path. And if I go into the scripts directory, so now my current working directory is scripts, I can get to this raw data file using, again, a relative path. And I do ... to go up one level in directory. And then I can access the raw data directory and then the raw data file. Okay, fantastic. Let's clear the screen. Okay, so we're in the scripts directory, and I'm going to create a file called analysis.sh. So I'm using the nanotext editor to do this. So here we can see the kind of key to the strategy that we're going to use here, and that is that we are going to always move in to the directory where the analysis.sh script is. Okay, and then we're gonna do everything from within that directory. So that means that we can use relative paths from within, from this .scripts directory. That means that we can run the scripts from anywhere, and we will always get the same result. Okay. But in order to do that, we want to make sure that at the end of when the script is finished, we go back to where we started. So the first thing that the script does is it saves the initial working directory. Then we go into the scripts directory And then finally, at the end, we go back to the initial working directory where we started off. So now I'm going to paste in a little bit more code here. So at this point, we create an environment variable to store where the derived data is going to be. And you can see here that this is a relative path with respect to the scripts directory that it's being executed from. And then we use the makedir command to create that directory. And we use the -p flag, and that basically means that it ignores any errors if the directory already exists. So we can run that command many times. And now I'm going to paste in a little bit more code. So this basically gets the raw data again as a relative path, and then it does some editing of that file using this stream editor called sed. So it replaces raw with fudged and isn't with is. And then it saves the data, so it redirects it into the derived data directory / into a file called deriveddata.txt. So that's the script finished. The details of the logic here doesn't really matter. The key things are that we save the initial working directory, then we go into the scripts directory, and then at the end, then we do some mangling of the data, and then finally we go back to the initial working directory. So I'm going to exit out of this using Control O for saving the file and Control X for exiting. Okay, so I'm going to go up one directory into my home directory, and then I'm going to make that file executable, so the chmod, so change the mode and then add the executable permissions of the scripts analysis file, like so. And at this point, we're ready to run the script, and we can execute it now basically by calling its relative path, or absolute path for that matter. And at that point, if I type ls, we see that we've had a derived data directory created, and we can see what's in there. We can do ls first, derived data. We see that we've got a file in there, and then we can look at what's in that file using cat. Yeah, fudged baked data isn't baked data. Okay, so let's try that again. So let's remove the file that we just created, go into maybe a temp directory, and we can call that scripts directory again. Let's do it using an absolute path this time. So you'll notice that I'm in a completely different location. I run it. If I type ls here, you see nothing has been created here. But if I do an ls in home, also t derived data, we can see that that file is there. And again, we can look at the content, and it's the same. So the key point here is that the script that you've created, it doesn't care where you're calling it from, because within it, well, the first step of the script is to go into the scripts directory where the script actually is. Then it works with relative paths within that script to fetch the raw data and to create the derived data. And then at the end of the script, it goes back into the directory where we were. So in this case, the temp directory. Great. Let's go into my home directory again. So cd is a shortcut for just going into my home directory. Let's clear the screen. Okay, so the other kind of benefit of doing things this way is that if we look at this, so we can see the directories that we have here, and I guess another way to visualize this is to use the tree application. you can see here clearly that we separated out the derived data from the raw data, and also we separated out the scripts into separate location. So this is really a key point of good data management. Don't mix your raw data with your derived data, because it becomes really complicated to keep track of what's going on. So here it's very easy to see what's what. So in the beginning I talked about portability. So what did I mean about that? Suppose that you've got a lot of stuff and you realize actually you want to reorganize things, and maybe you want to put all of this work that you've done here into a new subdirectory. Maybe you want to call it projects. So let's create a directory called projects. So now at this point, what I can do is I can move raw data into projects, and I can move scripts into projects too. And the derived data, I mean in this case, I know it's derived data, so I can reproduce it, so I can just simply remove it. So now if we look at this, we see we have the raw data and the scripts in this project subdirectory. Now I'm going to rerun that analysis, so I do projects, scripts, analysis, and then we can visualize what's happened. Boom, the derived data is present there again. Now if you had used absolute paths to refer to the raw data in your script, or for any other matter within that analysis.show script, that would not have worked, because the absolute paths would not be the same anymore. Okay, so that's what I'm trying to say in terms of the portability. If you use relative paths within your scripts, you can then later on reorganize the way that you've structured things without things breaking. I hope that makes sense. For more details, it might be worth reading the blog post, then give you a bit more time to digest what's going on. So a link to the blog post is available in the description of this video. And if you like the video, please give it a thumbs up and all that good stuff. Thank you.